We're getting there. Hey, dude, I can hear drums in the background. Awesome. Focus. It's a Friday. Focus. Suck it up. Focus. Section 5.2. Salts. Salts we use in food, but you know what? We're not just talking about for food. Salts have a very specific chemical definition. Okay? In science, salts are compounds that are produced in three main situations. The first situation is when you mix an acid with a base. When you mix an acid with a base, we call that a neutralization reaction because they're opposites of each other. They will tend to neutralize each other. And one of the things that will be produced is some kind of a compound, and we call that compound a salt. Not table salt necessarily, but some type of a salt. You can also get salts when you mix a carbonate, say what? With an acid. What the heck is a carbonate? Who has their pink sheet out? Carbonate is one of those polyatomic things on the back. What is carbonate? A carbonate is something CO3, potassium CO3, sodium CO3, something CO3, a carbonate. Third way you can get a salt is if you expose metal to acid. If you expose metal to acid. Do you remember when we did our lab, we dropped zinc into those 6 liquids and some of them fizzed? If you had left that there for days and days and days, you would have noticed a compound gathering on the bottom. It would have been a salt of some type. Zinc something. Salts are used for many things. Well, first of all, we use them a lot in food. Yeah, okay. We use salts in batteries. Our cells, the reason we like salt is we need salt to live. Our cells use sodium and chloride from salt to generate the potassium, sodium pumps that move energy in and out of our cells. Fertilizer. And then I wrote et cetera, et cetera, et cetera. It should be like et cetera, to like the 1000th power. They use all over the place. Okay. What's the first way that you can create a salt? Mixing an acid with a base. We have a fancy schmancy name for that. We call it an acid-base neutralization. Why is it a neutralization? Because acids and bases are opposites of each other. We said on our pH scale, bases are more than 7. Acids are less than 7, and they tend to neutralize each other. Hayden, you with me?
Yep.
You sure now? Okay. So, quick review. We said that acids release. Do you remember from memory which type of ions do acids release? Can you remember? Here's how you can remember. What does an acid begin with? And remember I said to you last day, Oscar, actually an H plus is a hydrogen minus an electron, which means it's a proton, if you really want to get fussy, but it's easier to write H plus. Bases release, what do bases end with? They release OH negative ions, hydroxide ions. And when you mix them together, you'll notice here we have how many hydrogens grand total in both of these? How many oxygens? When you mix an acid and a base together, you're going to get 2 hydrogens and an oxygen, and what's left over is a salt. Whatever other chemicals, Hannah, were part of the acid and the base will combine together. Here's an example. HCl, is that an acid? How can you tell? Starts with an H. Okay. Plus NaOH. Is that a base? Yes. How can you tell? It's got OH on the end. Now, this is hydrochloric acid, stomach acid, plus, what would I call this? What's Na? Sodium hydroxide. Okay. Gives you NaCl, sodium chloride. NaCl is table salt. The salt that you pour on food is NaCl, table salt, and water. I wrote, is this balanced? You know what? On this test, that's going to be not this Monday, but the following Monday, I am going to give you about 5 of these neutralization equations to balance. So this is a good chance for us to re-practice balancing equations. So let's draw a little line down the middle. I spaced this lousy. I retyped this handout last night after photocopying it, and I put more space in here. I apologize, Hayden. I didn't leave much space in front of the compounds to put numbers. We'll have to work with it. How many H's are there on the left? How many H's are there on the right? Oh, that's nice. How many Cl's are there on the left? 1. How many Cl's are there on the right? How many NAs are there on the left-hand side? Just 1. How many sodiums are there on the right-hand side? Oh, cool. Maybe this is balanced. What, am I missing anything? Oh. 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 Yeah, you got the joke. Okay. How many oxygen? Oh, how many oxygens are there on the left-hand side? Kira's going, I missed those lame jokes. I know. Sorry, 1. And how many on the right-hand side? Oh, is this balanced? We say, woohoo. Oh, that's nice. This is a acid-base neutralization reaction. Hydrochloric acid would burn you, Kenzie. No touch. NaOH is a base. It's probably caustic on your skin. No touch. But if you poured them together, mixed them up, and waited for a few minutes, put your hands in, no problem. You get a bit of water and a bit of salt. The acid and the base have been neutralized. Let's try another one. H2SO4, is that an acid? How can you tell? This is sulfuric acid. Plus AlOH3, is that a base? Yes. How can I tell? Ends in OH, 3 of them. Aluminum hydroxide. Those combine together, and if you mix them together, they will neutralize each other into aluminum. What is SO4 on my periodic table on the back there? What do I call that one? It's sulfide or sulfate or which one? Sulfate, aluminum sulfate, and water. Dihydrogen monoxide, if you really want to be fussy, Hayden. We call it H2O, we call that one water. I wrote down balance the equation first. Okay, let's balance this puppy. Let's draw a line in the middle. This one's going to be a fair bit trickier to balance, but this is a good review. On the left, I'll start out with the H's. How many H's are there on the left-hand side? Well, I got 2 and 3. I got 5. How many H's do I have on the right-hand side? 2. Well, is this balanced? We got work to do, but let's list everything else first. Now, I'm going to show you a new balancing trick. Amy, this is handy if you have those polyatomic ions, those ones from the back of the pink sheet. Do you notice this puppy right here is in brackets? It's from my pink sheet. I'm going to treat it as one funky atom. I'm not going to treat it as S separately and O4 separately. I'm going to say how many SO4s are there on the right-hand side? 1. See it, Ty? Yeah. How many SO4s, what did you say it was, sulfates? Are there on the left, on the left-hand side there's 1. How many on the right-hand side? You can do that, Amber, for polyatomic ions that don't get broken up. Now, hydroxide is also a polyatomic ion, but can you see it doesn't show up over here anymore, so I can't use that trick for that one. But here, since I noticed that it was in brackets here, that's a polyatomic, I'll treat that as, even though it's not on my periodic table, I'll treat it as one thing. Trust me, it'll make the balancing easier. Let's keep going. How many aluminums are there on the left-hand side? How many aluminums are there on the right-hand side? 2. How many O's by themselves, not counting the ones in the sulfate, how many O's by themselves are there on the left-hand side? I've already used this one up there. Ignore it. How many O's do I have just here? 3. How many O's, not counting the ones inside the sulfide? I keep saying sulfide. Sulfate. How many O's do I have? Just this one here? All right. Suggestions. You know, since hydrogen appears all over the place, I'm going to try saving that for last and hope it kind of takes care of itself, maybe. I think I might start with the aluminum. I hope. How many aluminums are there on the left-hand side? How many on the right-hand side? So maybe I need 2 of those. Now to get that, I've got to put a 2 there. Right? But that's going to change a bunch of other stuff because now, if I put a 2 there, how many hydrogens do I have on the left? 2 plus 6. How many do I have now? Okay, I'll deal with that later. I'll come back to that. Oh, and how many O's do I have? Not counting these ones because we're treating that as one funky compound. How many O's do I now have? There was 3, now I have 6. Okay. But my A's match. Any thoughts now? I might try the SO4s because that's one funky one. I'm really hoping that the H's and the O's will tend to domino through and take care of themselves because those are the ones that are spread out the most, Jess. So, Leah, how many SO4s do I have on the left-hand side? 1. How many do I have on the right-hand side? So are you saying I need 3 of them over here to balance? So I'm going to put a 3, yoink, right there. It's going to give me 3 of those. Ooh, that's going to change the H's again. Yes? How many H's do I have? 6. And 6 more. How many H's do I have? I got 12 now. Are my ALs, my aluminums, balanced? Yes. Check. Are my sulfates balanced? Yes. All right, let's go tackle the hydrogens and the oxygens. Let's see. How many hydrogens do I have on the left-hand side, grand total? How many do I have on the right-hand side? How can I change a 2 into a 12? You know what? I might try putting a 6 right here. That would give me 12 of those. Woohoo! And how many oxygens will that give me on the right-hand side? Holy smokes! Are we balanced? Let me see. How many, Jess? 12? How many? How many? How many? Oh, this is not. How many? How many? How many? How many? Are we balanced? Yes. Apparently, the actual equation is 3 H2SO4s plus 2 AlOH3s results in aluminum sulfate and lots of water. Here's your salt. Here's your water. Okay? Let's rewrite this nicely and neatly. So we can write this as 3 H2SO4 plus 2 AlOH3s results in Al2SO4 3 plus 6 waters. So the next question asks, state whether each of these is an acid, a base, or a salt. What would be a good letter to use for acid? What would be a good letter to use for base? What would be a good letter to use for salt?
S.
Thank you. A. What do you think? How do you know? Okay. We might need more proof, but if I had to guess, yeah, let's go with it. We're going to go across to L. Does it start with an H? Does it end with an OH? Then logically, what is it probably? B. Right? M. This is the weird, funky acid that unfortunately doesn't follow the rules that you're going to have to memorize, because I know it ends in OH, and I know it doesn't begin with an H, but it's vinegar, it's an acid. Pardon me? We're going to find out. Let's see. Let's see C. Base. Ready, Brendan? Brendan said, does that mean ends in acid? Let's see. Does it start with H? No. Does it end in OH? Does it completely have that Chaku thing in it? No, it's not exactly. It's a salt. By the way, it's the salt that you would get if you mixed magnesium something with vinegar. The magnesium would bond with those ones, and you'd have water left over. Yes, magnesium acetate. Thank you. I haven't memorized these polyatomic ones, and I need a pink. You know what? I got a pink sheet in front of me. Right there, Captain Obvious. Okay. D. O. How do you know? Okay, and if it was a word, it would start with hydro, right? Or it would have the word acid in it. And if it was a base, it would end in hydroxide, or be some kind of chemical that we knew was a base, like ammonia or bleach. So you're saying it's a salt? So can you see, Kenzie, we're going process of elimination. We figure out acid or base first. If no, it's a salt for now. So here's your challenge. Try doing this here on your own. I'm going to give you about 60 seconds. I'm going to freeze the screen and do them up here. Let's see if we get to the same spot. I'm going to try and freeze the screen. I'm going to recognize that my battery has died, apparently. My battery has died. I'm going to... No, I can't do that, Mr. Duick. Well, I'm going to do it quietly up here. You try it on your own. Let's see if we get the same thing. Hopefully you all get Q right. Hopefully you all get T right. I got, going down the first column, BAAA-SBB. Going down the second column, sodium chloride threw me for a second. Oh, no, that's NaCl. It doesn't start with an H. There's no OH, so I just kind of visualized the chemical. Salt, acid, acid, base, salt. Okay. let's try balancing a couple of these together. These are the practice problems. I copied them out from page 236, numbers 1 to 5. The answers are on page 592, but we're going to walk through these together. The first one, I did the right-hand side for you. Let's see if we can figure these out. So HCl, acid, plus KOH, base, gives KCl, potassium chloride, plus water. Let's double check. Is it balanced? How many H's do I have on the left-hand side? 2. How many H's do I have on the right-hand side? How many? Oh, is H2? Okay. I think I make this a bit bigger. That's better. How many Cl's do I have on the left-hand side?
1.
How many Cl's do I have on the right-hand side? Oh, I like that. How many K's do I have on the left-hand side? How many K's on the right-hand side? How many O's do I have on the left-hand side? How many O's on the right? Hey, this one is balanced. Let's do the second one. H2CO3 plus MgOH2. Now, here's what's going to happen on the chemical level. Brad, this H is going to combine with that to form water, which means the salt is going to be this one and that one. And I'm going to write the metal first. Which is the metal, the CO3 or the Mg? So the actual chemical reaction is going to be MgCO3 plus H2O. Oh, but for this one here, I got a crisscross. What's the charge on CO3 from the back sheet there? 2 negative. What's the charge on magnesium, Mg? 2? Oh! So when I crisscross, it's 2 and 2, which reduce to 1 and 1. This, in other words, I don't need to put any subscripts here. All right. Let's balance. How many H's on the left? How many H's on the right? On the left, I see 2, 4. Yes? On the right, I see 2. I have a feeling I'm going to have to put a 2 in front of the water later on. Let's treat, because that CO3 appears on both sides together, can we treat the CO3 as one single particle? So I'm going to say, how many CO3s on the left? 1. How many CO3s on the right? 1. What else do I need to take care of? Mg, how many Mg's on the left? 1. How many Mg's on the right? Ooh, I like. Oh! Oh! I'll never get tired of that joke. How many? Now, I counted this O3 over here, so don't count it twice, Sarah. Just count this one. How many O's are there, Sarah? You say 2? It's hard for me to tell because you and Hayden are trying to sink into your tables. Want to give Hayden an elbow for me? He's alive? I knew I could count on her. Okay. The elbow was a bit mean. Hang on. Okay. Darian said, hey, Mr. Duke, I don't know how you got the MgCO3. I know the H2O is a product. We said that when you mix acids and bases, you get salt plus water. So I did the plus. Come here, pen. I said, I know that's going to be there. Well, what else do I have on the left that can combine? That, yes? And that funky polyatomic molecule. Oh, and I wrote the Mg first because don't we always put metals, then non-metals when we're writing bonding? If you're still stuck, we're going to do a couple more. It's going to become clearer. Anyways, let's finish our bonding. How many O's do I have on the right-hand side right now? 1. I think I can solve the whole thing by putting a 2 there, can I not? That's going to give me 4 hydrogens, 2 oxygens. Okay? We're going to skip number 3. We'll come back to it later. Let's do number 4, because 4 is a little bit clearer. My argument here, Darian, is acid, yes. Base, yes. So I know that the reaction product is going to be something plus water. What something? Well, what haven't I used yet? That's over on the left-hand side. What do you see? Sodium, which is going to show up first because it's a metal, combined with PO4. Now I'm going to have to crisscross for those. So I'm going to write sodium and PO4. What's the charge on sodium? 1? Not nothing. There's a 1, isn't it? What's the charge on PO4? Got to look it up. That's why I said get the pink sheet. Brady? Sorry? So I think, don't write this down just yet. We would go 1, 3, crisscross. We're going to have 3 of those and 1 of those. Is that what you're saying, Brady? Okay, there's our crisscross rule. Did I answer your question now, okay, Darian, where it comes from? It's water, and then the other ones combine. What do I mean by the other ones? The non-hydrogen oxygen. This is tricky. Don't kid yourself. Let's balance. Please tell me this is going to be a fairly easy one because I haven't done this one yet in my notes. We'll find out. How many H's on the left-hand side starting out? 4, right? How many H's on the right-hand side starting out? 2. Oh, I can fix that probably by putting a 2 in front. I'll keep that in mind, but probably I'm going to put a 2 right there. Yes? Hey, let's do that trick again of treating that PO4 as one single atom, it is a polyatomic molecule. So I'm going to say, Ty, my friend, how many PO4s do I have on the left-hand side?
1.
Nice. You with me? How many PO4s do I have on the right-hand side?
1.
By the way, what PO4 is? Phosphate. How many phosphates? 1?
Yeah.
I like that. How many sodiums do I have on the left-hand side, Oscar? You with me now? How many sodiums do I have on the left? I know, I caught you looking. Yeah. I'm watching back there. I see all, I know all, I smell all. Believe me, I smell all. How many sodiums do I have on the left-hand side? How many sodiums do I have on this side? Count. 3 where? What's sodium look like? You got your periodic table in front of you?
No.
Okay. Oscar, thank you for volunteering to stick around after school because I'll walk you through the bare minimums then. Get it out and keep the notes in front of you. You can't do both at the same time, my friend. Take the periodic table physically out of... You got it? Okay. I'm going to go one further. Amber, my child. Here's sodium. How many of them do I have? 1, 1. How many... Because the next thing I run into is oxygen. How many oxygens do I have? How many sodiums do I have on the right-hand side, Amber, my child? Yeesh. How many oxygens? Not 5, because we're counting that as one single atom. How many oxygens do I have? 1. Okay. Well, I think for sure I'm going to need to go 3 of those, because that's going to give me 3 sodiums to go with 3 sodiums. Right? What else does that change? Changes the number of oxygens. Oh, come back. Come back. Back to the middle. Changes the number of oxygens to 3. And it changes the total number of hydrogens. 3 in the front and 3 in the second one. 6. Okay. Hey, sodiums match. Woohoo! Now what?
2 in front of the H2O, or 3 in front of the H2O.
2 or 3?
3.
Why 3? How many H's do I have on the left?
6.
How many H's do I have on the right?
2.
So you're saying if I put a 3 right there, that'll give me 6 of those. Oh! And that'll also give me 3 of those. And Jessica, correct me if I'm wrong, I'm balanced. Yeah? 6, 6, 3, 3, 1, 1, 3, 3. Yes! Yeah! Let's try another one. Example 5. acid plus base, see the acid, Darian? See the base? Results in water, and the other ones are going to combine. There's an NO3, which according to my sheet is nitrate, and a calcium. The calcium is the metal, Hannah, so it's going to be calcium NO3 nitrate. Oh, but I got to crisscross to make sure those balance. By the way, you notice, Hayden, I'm not bothering to crisscross the water because water is H2O. I got that one memorized. Calcium, what's the charge on calcium? 2. What's the charge on nitrate? Or did I say nitrate or nitrite?
1.
NO3. 1? So when I crisscross, I'll need a 2 there, and well, I guess I don't need to put the 1 there, but I'll need 2 of those. NO3 in brackets, 2 of them. Let's balance. Do you guys want to try this one on your own? I'll do it up here quietly. Let's see if we end up in the same place. So Curtis, try this one on your own. If you get it wrong, no one's going to know. Well, I'll know because I know everything. No, I won't. I'll try this one myself. If you get stuck, you can kind of look up. Do your counting, if nothing else. I get that when I list how many of each there is. I think. Double check. 1, 2, 3, 1, 1, 2, 2, 2, 1, 1. Yeah? You know what I'm going to tackle first, though? I think the first one I'm going to tackle is that polyatomic ion, because that's a big clump, and I'm hoping that'll domino the hydrogens. I know I have 1 NO3 on the left, 2 on the right. No matter what's happening, Darian, I definitely am going to have to put a 2 right there. That gives me 2 of those and 4 of those. Okay. Now what? How many hydrogens do I have, Darian, on the left? How many on the right? How about put a 2 there? That's going to give me 4. Oh, and that's going to give me... Oh! Holy smokes, I think we're done. I think we're done. So on your test, eventually you're going to be balancing a couple more equations. Folks, by the way, I see a bunch of you zoning out. Hey, it's a Friday, suck it up. Because I'm 3 classes behind the other classes, so we got to catch up. Next page. So we just talked about what are called acid-base neutralizations. The next thing we're going to talk about are oxides. What are the first 2 letters of the word oxides? What chemical do you think, what compound, what atom do you think oxides contain? I wrote it in brackets, oxygen containing, but Laura, I'm going to pretend that from the word oxide, you probably could have figured that out. Okay? So we have a couple of oxides, 2 types, metals and nonmetals. What do you think a metal oxide contains? Begins with the letter M and rhymes with ethyl. And also some oxygen. What do you think a nonmetal oxide contains? Not metal and an oxygen. Okay, we're going to flesh this out, but I'm trying to give you ways. You can memorize this, but Alon, I think you can get some of this from the words. Yes? So, compounds that contain a metal ion, and then oxygen ion. If you mix these in water, these produce basic solutions. Say what? Show you. What's that? We're going to mix it with water. What's this? It's an oxide. How do I know? It's got oxygen in it. What kind of an oxide? Metal or non-metal? What's Na? What's sodium? Are you clued in why I said it was smart to get the periodic table up, by the way? Yeah. Sorry? Sodium is a metal? This is a metal oxide plus water. So this is an equation, what I just described. They're going to combine. What are they going to combine into? They are going to combine into a base. They're going to combine into a base. Oop, but I got a crisscross. What's the charge on sodium? What's the charge on hydroxide? Oh, when I crisscross, what do I get, Josh? I caught you zoning out, I know. 1 and 1. This is going to form NaOH. Sodium oxide plus water gives you sodium hydroxide, a base. Let's try the next one. What's the second chemical compound you see, the one that appears after the plus that has the H and the O in it? Water, so we're mixing it with water. What's the first compound? Ca, what's that? O, what's that? Calcium oxide. Calcium, metal or non-metal? It's going to form a base. What base will it form? Well, it's going to form calcium, and what does every base end with? It's going to form that, but we got to quickly crisscross. I'll do that over here. Calcium, OH. What's the charge on calcium from your periodic table? Hydroxide? 1. Oh, it's going to be calcium, OH, 2 of them. That's the chemical reaction going on there. That's the oxidization reaction going on there. Okay, lots of new stuff, but I'm trying to show you that you can get a lot of it, Amy, from the vocabulary, from the words. Oxide contains oxygen. Metal oxide, better be a metal in an oxide. What are the metals? That's from last unit, the left side of your periodic table. Oh, non-metal oxides. These are compounds which contain a, what do you think? Non-metal. And at least 1 oxygen. Often they'll contain more than 1 oxygen. Let's see if we can guess this. What do you think? If metal oxides mixed with water produce bases, what do you think non-metal oxides mixed with water might produce? Acids. Okay. Here's an example. SO2 plus H2O. What's H2O? So we're mixing something with water. SO2, is that an oxide? How do you know? Now, what's the first letter? Sulfur, metal or? Oh, there's a non-metal oxide. It's going to form an acid. If it forms an acid, what's it going to start with? There's going to be an H in front. And then the other ones are going to end up forming SO3, which is on the back of your sheet. How did you know it's going to form SO3, Mr. Dewick? I cheated and looked it up. You don't have to get quite that advanced. But for what it's worth, I wanted to show you the correct chemical reaction. Ooh, is this balanced. Oh, did I balance these other ones? I think I forgot to balance these ones. Let me see. 1Ca, 1Ca, 1, 2. Oh, no, those are balanced. First of all, what's the charge on hydrogen? 1. What's the charge on S? It doesn't matter. I think it's plus or minus 1. What's the charge on SO3? Is 2 negative. So it's going to be H2. That's sulfurous acid. Don't put your hand in there. And by the way, I think we are balanced, are we not? Isn't there not 2 hydrogens, 1 sulfur, 3 oxygens, 3 oxygens? Oh, it is balanced. It says classify each of the following as a metal oxide or a non-metal oxide. How about MO for metal oxide and NO for non-metal oxide? Yeah? Okay, that works. A.
Metal.
Mo. B, straight down.
Non-metal.
Is what is B? Boron? Where is boron? It's a non-metal? C, nitrogen oxide. Be nitrogen dioxide because it's covalent. D. Oh, I wrote non-metal. Oh, heck, actually NM. I should probably go like this. How about non-metal oxide? Hey, that works. C, metal oxide. E. Non-metal oxide, sulfur. F, beryllium, metal oxide. G, H, another question we might ask you very simply is, hey, tell me whether an acid or base will be produced. Metals produce base, non-metals produce acid. I haven't yet come up with a good way to remember that, so all I can say to you, memorize it. Sorry. I'm trying to come up with a stupid acronym or whatever. If I come up with one, I'll let you know. But for now, metals produce base, non-metals produce acid. Maybe you can think heavy metal band has lots of base. I don't know. Whatever you can try and come up with. Okay? What's a heavy metal band? Oh, shut up. I grew up in the 8th. Yeah. So that first one, acid or base, what do you think? It all depends on what that first compound is. Is it a metal oxide or a non-metal oxide? Magnesium is a metal. It'll produce a base. B, straight down. That'll produce an acid. C, straight across. Calcium is a metal. Base. D. This is a problem. What is that first chemical? You've seen it before. What is CO2? See, part of the problem when carbon dioxide goes into the air, it combines with rain. We call this acid rain. This is where it comes from. Pollution. So what? Turn the page. Well, when coal, oil, etc. are burned, they combine with oxygen to form non-metal oxides, like CO2 and carbon monoxide, CO, and others, which then dissolve in rainwater. And when you add a non-metal oxide to water, what do you get? Acid rain. There's a lovely picture, but this is where acid rain comes from. I gave you a couple of pictures. Picture on the left here, if you turn the page, it's from 1908. Picture on the right is from 1968. Hey, what do you think happened? Yep. Yep. And you can find plenty more. I found this pretty quickly. Many of them are really depressing because a lot of them show wildlife and animal. Ugh. I'm just like, that doesn't look right or good. But here's one from a building. Next page. So, acids react with metals. What happened when you dropped zinc into the acid during that experiment? What did you notice? Bubbles. A gas was being produced. Which gas? And I'll tell you how you can figure it out. What do acids begin with? So if a gas was going to be given off all the time, what's the common gas that all acids have, although as a liquid initially? Hydrogen. Hydrogen gas. Bubbles.
What about flammable then?
Yep. Very. The most reactive metals are the ones on the very left on the periodic table. What do we call the ones on the very left of the periodic table? The alkali metals. And the lower in the periodic table they are, more reactive. Francium, which is in the bottom left corner of the alkaline row, is extraordinarily reactive. Put your pencils down, look up.